Hi, I'm Chaukaze Anakago, and I'm doing my project on how smell affects taste. The tongue can detect 5 basic tastes: sweet, sour, bitter, salty, and savory, while the nose can detect odorants. Both organs working together create what we perceive as flavor. My hypothesis was decided by using the information I gathered beforehand. I hypothesized that if you blindfold and plug up a person's nose, then they will not be able to taste anything, since both the nose and the tongue work together. For this lab, you need 20 volunteers for both trials. First, pour your Skittles into a bowl. You will need 2 Skittles of each flavor. Your volunteer needs to either have their eyes shut or be blindfolded throughout the entire lab. Tell each individual to plug up or close their nose. Hand them a Skittle. Give them a few seconds to identify the flavor, and then mark down a check if they guess it correctly, and if not, put a 0 indicating that they got it wrong. My independent variable is the sense of smell versus the nose sense of smell. My dependent is the ability to taste and identify the different flavors, and my controlled was the closing of eyes, same flavors throughout the experiment, and the same people for each trial. In my hypothesis, I am testing how the nose affects the tongue's ability to taste. I knew in the lab I was blocking people's ability to smell. That was the variable I was changing, and that's how I knew my independent variable. In the graph, the green bars represents the ability to smell, while the blue bars represents the absence of smell. You can see in the first trial that over half of the volunteers with smell present had all correct guesses. On the other hand, take away this sense of smell, and none of the volunteers could guess all the flavors correctly. Here you see 2 volunteers closing their eyes, holding their nose, and tasting the Skittle. And you also see the data tables from the first trials of one open nose and another closed nose. In trial 2, you see the same results occur as what you saw in trial 1. Over half of the volunteers had all correct guesses when their nose was open. But you see a slight decrease. In trial 1, 15 volunteers had all correct guesses, and in trial 2, only 14 had all correct guesses. In both trials, 13 volunteers had 2 correct guesses when their nose was closed. Here you see the data tables for trial 2 for closed nose and open nose, and you see 1 volunteer with their eyes closed, nose closed, and eating a Skittle, and in this one you see only a volunteer with their eyes closed and about to eat the Skittle. 22.5% was the average of correct guesses when a person's nose was plugged up. Here, this proves my hypothesis because there was such a small percentage of right answers. Many other factors can contribute to how people taste things. For example, in Quinn Janice's Wings experiment, she found that people's sense of hearing can have an effect on how people taste different foods. The 5 senses are all intertwined with one another. Many researchers have found that if one sense is cut off from the rest of the body, another sense will intensify to replace what has been shut down. You can see this in the real world today. Many restaurants will use diffusers to expand the smell of many food fragrances, while they also play music which makes people feel more calm and relaxed in their environment. Here are the 2 senses, smelling and hearing, working together. The experiment could be expanded to multiple age groups. You can see how aging affects the sense of taste and smell, and how, as people age, their taste buds decrease. In conclusion, the lab proved my hypothesis, since there was an almost 70% increase in correct guesses when the sense of smell was available. Thank you for listening.